Hello, today we're going to be talking about quantitative genetics, and specifically, selection. To illustrate this concept of selection, I have chosen a problem that has to do with the fur size of cats. A long-haired cat's fur length ranges from 2 to 6 inches. So today we're going to be breeding the top 10 population of long-haired cats. And to do that, we're going to analyze these values. So as I said earlier, we have selected the top 10% of our population to breed. And here's a histogram I made after calculating all the values I needed to calculate. And to do these calculations and to get the histogram, I had to choose an original mean and a standard deviation. So I chose 6.35 centimeters and a standard deviation of 2 centimeters. So to calculate the selection difference, we need the selection intensity and we need the standard selection point. And to get our selection difference, we just multiply the selection intensity and the standard selection point. To get the mean of the individual selected to be parents, which is the top 10 that we got, we derive a formula from the selection difference formula, which is selection equals mean of selected population minus mean of original population. And here we're just going to derive the formula of the mean of selected population, which is going to give us the mean of selected population equals the selection difference plus the mean of original population. And that gives us 9.86. And here on the graph, we can see that the mean of individuals selected to be parents is denoted by x sub s. To get the response from selection R, we derive a formula from the realized heritability formula, which is h squared equals response from selection divided by selection difference, and h being the realized heritability. 0.576 centimeters as our response from selection. To get the mean of offspring x bar sub 1, we derive a formula from the response from selection formula, which was x bar sub 1 minus x bar sub 0, so the mean of offspring minus the mean of the original population. After deriving our formula, we can add the mean of the original population plus the response from selection to get our mean of offspring x bar sub 1. And to get our truncation point, which is x sub t, which is the point of selection where we choose the parent to breed, we use the formula x sub t equals mu, which is also the mean of the original population, plus z and sigma times sigma. And here we can see the truncation point in red dotted line. And to just give a further understanding of the histogram I have here, the green curve represents the first generation of the offspring after breeding the selected population. The yellow curve represents the original population of long-haired cats' fur length. The yellow line, denoted by x bar sub 0, is the mean of the original population. The green line, denoted by the x bar sub 1, represents the mean of the offspring population. And x bar sub s represents the mean of the individuals selected to be parents. The pink horizontal line denotes the selection difference between the mean of the individual selected to be parents and the mean of the original population. The orange horizontal line represents the response selection between the mean of the offspring and the mean of the original population. Now I just want to give a reason why the selection response may decrease. It may decrease after some generations because the furs may reach a very high length that may not be healthy for the cats, and it may not be suitable for cat owners to groom or to keep up with. So generally, since people tend to like cats with longer furs, and the mean of our offspring population is higher than the mean of our original population, I would say that the selection experiment worked. Thank you.